Welcome to Cell Electrical, Electrician's Guide to Fire Alarms. I'm Matt Cell. Going to conquer a very quick guide to fault finding on this one, as requested by a very handsome follower of mine. So, yeah, the basics are that, well, do you know what, let's start. How does a fire alarm panel work? Let's zoom in, and I bring a Floyd energy to engineering videos that people don't really like. Right, so it's a conventional panel, very conventional, separate sounder circuits. These are radial circuits in essence, but when you get to the end of the circuit, you have an end-of-line device. So for your zone cabling on this CFP panel by CTEC, it is a capacitor rated at farads. And on the sounders, in here will be an end-of-line resistor. I want to say it's 10k, can't remember, but it will differ panel to panel anyway. Read the effing manual, figure it out. Read the manual ahead of doing anything. And basically it's looking for different resistances for different things. So this sees the end-of-line capacitor, therefore it's a complete circuit. It's not seen any other resistors to tell it anything else is going off, so that's fine, that's happy, right? And then you get around it and go through here, cabling in and out, right? And that is just going in and out because the circuit hasn't been broken, we haven't pushed this. And it goes into this one, which has the end-of-line device in. I'd have liked to have done you a longer circuit, but I just didn't have the things around. But in here is the end-of-line capacitor because it is a zone. And that's it, right? So that is healthy. If we were to push this, or if this was to see some smoke, it would throw, I think, 470,000 ohms at this terminal, right? The circuit board would then see it and go, we are on fire, and it would set off the sounders, okay? Or like the sounder circuit would trigger, and then whatever that's doing, be it like visual alarm devices like that, that would go off. When healthy, it's looking for other things. So for instance, in this smoke detector, it has a diode across the in and out terminals. So if I was to move this, this goes into fault, right? Let me just silence that beeping. The reason being is, I don't think you can see it, let me Floyd you in there. We got, oh God, I'm terrible at this, I just don't want to do any editing. This is our end-of-line capacitor, and this is our diode, right? So now, because I've taken away the smoke detector, which connected it through, same as with the cool point, I've taken this away, so now it's presented it with this diode, right? So this diode is telling the panel, right, the panel is seeing this diode, so it knows something's gone wrong. It has an open circuit. Yeah, cool. So I'll put that back on. Oh, in fact, yeah, I'll put that back on. Reset the panel. Fault's cleared on zone 3, which is that zone. And there we are. Right, different kinds of fault. So you've got open circuit. Makes sense, you're an electrician, you must understand what an open circuit is. Basically, what's going out, coming back, there's a break in it. So normally, the end-of-line resistor might have failed. End-of-line device, be it the capacitor, resistor, whatever, that's failed, that's missing, that's gone. Or you've got a head removal, will give you open circuit. Or you literally have a break in the cabling. It's a poor connection, it's fallen out, whatever, buildings vibrate, terminations have come loose, it happens. You also have short circuit. You're an electrician, you know what a short circuit is. Pos and neg, live and neutral, they're getting to know each other a bit better than they should. That can be a dirty device, that can be introducing, it could be a cable fault. I mean, if you really touch down pos and neg on a live panel, so you've got your 24 volts going out of there, quite often it can actually damage the panel, right? It's too little resistance for it. Or you have a nerve fault, right? again, you're an electrician, you know what an earth fault is. It trips your RCDs. So you've got your going to ground somewhere, right? The screen cabling, right, this is in green and yellow sleeving here, right, which is earth sleeving. Incorrect, it should be pink because it's a functional earth. But that is connected not to your 230 volt earth, but that is connected to the circuit board earth, right? On a metal panel, it might go to the bodywork of the panel. It's not an earth cable, it's a screen cable, or if you're using FIKE, it's a data cable. But in essence, it's cleaning up the path for everyone. But if the cable's gone down a bit, it could be sending voltage down here, which is going into the circuit board. And if the panel does report earth faults, it'll give you an earth fault. Yeah, if you take over a panel and you notice that this has been disconnected, it's because there's an earth fault somewhere and some shyster has just removed it to get rid of the earth fault. Don't do that. So how do we fault find? Well, same as process of elimination as you would do in any radio or ring circuits, right? So what I'll do first, take the end of line device, take the zone cabling out, put the end of line device in, and then if the fault clears, then you know the panel's fine and it's going to be to do with the cabling, right? Heads up, don't do this live. Or you might get away with doing it live at the panel end, but anything you're doing out in the field, kill the panel, or at least make sure that you're not sending voltage down there. Take those cables out. But yeah, put that end of line device. We know that, get back in there, sorry, that's the terminals going on that. In this instance, I would have found out it's the panel that's failed. This is why this is on my garage floor and not in someone's house. So you've proved the panel's fine. You want to find where the fault is in the field. So take your end of line device, go to the middle point of the circuit, and this is why we provide drawings, because if you're new to the site, you don't know the wiring routes. So you want to go halfway, as per your drawing, split the circuit in two, put your end of line device in, does the fault clear? Yes, then you know it's the second half of the cabling. No, you know it's the first half. And then basically, process of elimination there, split it in half again, half again, half again, until it'll tell you where the issue is. You should then, you know, oh, I found a smoke detector full of cobwebs. It's probably that. Change the head, see how you feel. Or it's the cabling, in which case, you know, you're an electrician. So separate that cabling from the rest of it, get your meter on there, insulation resistance, continuity. Obviously, do not put 500 volts down cable that is connected to the panel, you'll blow it up, right? This is all rated at 24 volts. And really, that's it. That is fault finding on a conventional system. That's basically it. Once again, if any fire alarm engineers watch this, think I've missed something that, you know, a spark's just learning fire alarm panels should know, hit me in the comments, I'll make some adjustments, whatever. That is really it, to be fair. Process of elimination stuff, it's the key is, do you know the panel? Do you know how it works? Do you know what resistances it's looking for, what the end of line devices are? So before you touch anything, you get a PDF online somewhere, read the manual, check what it's after, what it's about, what functionality it has to help you fault find. Like for instance, this CFP panel, right? I think I've cleared that cable fault. So get this, right? Let's just turn that beeper off, right? I've got a fault on zone 3, but I can go through this and it will get to the fault finding bit and then open circuit, solid zone 3. So I already know I'm looking for either end of line, head removal, whatever. You know, but different panels have different functionality. It's just knowing your panels. Get on there, you. There you go, bloody thing. questions, let me know. When I get something a bit more advanced on this, I'll do more advanced stuff. Thanks for watching. Yeah, any comments? That's the sound of my recycling bin. Bye.